Hey, it's Buono. So here we're going to talk about the very basics. What even is electricity? Detecting light, spinning a motor, your computer doing literally anything. All of that runs on electricity. It's everywhere, like actually everywhere. So before we dive deeper, let's make sure we've got the fundamentals locked in. Okay, let's zoom into the micro world and actually see what electricity looks like. Electricity is basically electrons flowing in one direction, and those electrons originally live inside atoms. Picture a copper atom up close. There's a positively charged nucleus in the center with electrons orbiting around it. Since the positive and negative charges are equal, the whole thing is electrically neutral. Now here's the thing. Electrons orbit in multiple layers, and the inner ones are locked in tight to the nucleus. But the outermost electron? It's far from the center, so the bond is super weak. If we simplify this into a basic model, it's just a positive center with a negative electron circling around it. Easy. So let's jump inside a copper wire. It's literally just a bunch of copper atoms lined up next to each other. Because that outer electron is so loosely bound, neighboring atoms end up sharing electron paths, meaning electrons can move freely between them. But at this point, they're just bouncing around randomly. No direction equals no electricity yet. The magic happens when an external force pushes them all in the same direction. That's when electricity actually flows. And by the way, that external force, we call it voltage. The flow of electrons, that's current. One weird thing though, electron flow and current flow go in opposite directions. Sounds confusing, but it's literally just a naming thing. Electrons were discovered after current was already defined, so they just ended up backwards. Don't overthink it, lol. Now here's something that'll make everything click way easier going forward. Electricity and water behave almost identically. In the electrical world, voltage pushes the electron closest to the positive side first. That electron moves, leaves a gap, and the next electron fills it. Then the next one fills that gap. Repeat forever, you get electron flow. In the water world, a pump adds pressure to water in a pipe. The water molecule closest to the downstream end moves first. The next one fills the gap. Then the next. Repeat arrow, you get water flow. See how they work the same way? Once you get this analogy, a lot of electrical concepts start making way more sense.